First step, let's label our three equations, A, B, and C. We're going to start with these two equations here because notice they only have two variables, and that's what we're accustomed to solving. And since we're using substitution, looking at those two equations, B and C, I see that the Z is easiest to isolate for in equation B. And if we do that, we get negative Z is equal to 9 minus 6y. Multiplying everything by negative 1, we get that Z is equal to negative 9 plus 6y, or we have that Z is equal to 6y minus 9. Next, I'm going to sub this equation into the other equation, C. So we get that 3y minus 2 times our 6y minus 9 is equal to 15. So here's our substitution step. Now we need to expand and solve for our single variable. So we get 3y minus 12y plus 18 is equal to 15. If we collect our like terms on the left side, our 3y and our minus 12y, we get minus 9y. If we minus 18 from both sides, so we have the constant on one side, 15 minus 18 is negative 3. Finally, we can divide both sides by negative 9. And if we simplify that fraction, we get y is equal to 1/3. So we now know what y is equal to. So we're going to take that y value and sub it into one of our two equations, B or C. Or even better, let's use our equation for z, where we said z is equal to 6y minus 9. Recall that 6 is the same thing as 6 over 1. So we get that z is equal to, well, 6 times 1, numerator times numerator, is 6. 1 times 3 is 3, minus 9. And we get that z is equal to 2 minus 9, which equals negative 7. So now we have the z value. Finally, let's take the y and z value and sub it into equation A. And if we do that, we get 2x plus 3 times a third plus 4 times negative 7 is equal to 12. Remember, that's 3 over 1. So we get 2x, and then we get 3 over 3, which is 1. So we get plus 1 minus 28 is equal to 12. On the left side, we're left with 2x. These two numbers combined here is negative 27. So if I add 27 to both sides, that'll get rid of the constants. 12 plus 27 gives us 39. So therefore, x is equal to 39 divided by 2. So now we have our x value. So we can say, therefore, x, y, z is equal to 39 over 2, 1/3, and negative 7. So there are the values for x, y, and z for this system of equations.